Good day, viewers. Welcome to Science Spectrum with Don. This is Math 188, the fundamentals of mathematics, and I would talk about the fourth and the last type of variation, which will bring this topic to a grinding halt. So this will be the fourth part of the second lecture, and then I'll talk about partial variation. Partial variation. So far, we've looked at variation to be the quantitative relation between two or more quantities. And we also talked about the types of variation, starting off from direct variation to indirect, to joint, and now to partial variation. So, what is partial variation? It is simply any variation that is expressed as a sum of terms. So this is partial variation is variation that is expressed as a sum of terms. All right, so let me give an example. Let's take, for example, let's say a quantity x. Okay, let's say I have a quantity x, and I tell you that quantity x is partly constant. X is partly constant. And partly varies as the square of y. So how do I really express this quantitatively? So the first statement is x is partly constant before the and. So x is partly constant means this. X is partly constant. And is a plus. The same x partly varies as the square of y. So x partly varies as the square of y. So how do I really put this together in such a way that I could express this now as sum of terms? Alright, so this would imply that I could stick in an equals to sign for this, and I have an x on the left, followed by a constant of proportionality, and I could just use the k for my convenience for now. Then, there goes the plus, the and. Now x, right, varies as this, x partly varies as the square of y. So I could replace this sign with an equal to, followed by a constant now, which is somewhat different from the k. So I could use any letter of the alphabet. So let me use, for my convenience, let me use a letter L. And I have an x on the left, and I have y squared on the right. So if I join everything together, right, so express as the sum of terms, my x is the same, so I'll pick one of the x. The equal to is the same, and I have a constant here, k, plus this term here, that's L y squared. So I've expressed this statement mathematically as a sum of terms. So this is variation as it's being expressed as a sum of terms. So I could give I may need to write this off. Alright, so I could also write another statement. Let's take, for example, let's say x, let's say quantity c now, okay, varies partly. Quantity c, let me write it in words. So c varies partly as y, and partly, okay, as the inverse, of the square of y squared. So I could write this now as the first term here, c varies partly as y, and is a plus. Then the next statement is the same c, okay, varies partly as the square as the inverse of the square of y. So C varies partly as the inverse of the square of y. So this will boil down to be, I could replace this sign with an equals to followed by a constant of proportionality. I have a y on the right and I have a c. This is the first statement. Then followed by the and, I could replace this sign with an equals to now followed by a constant, which is somewhat different from the k. So I could use L for my convenience. You are free to use any letter of the alphabet, right? So I have L times 1 gives me an L, so I have over y squared. Then I could write this equals to here. Then I have a c here. So if I rewrite this properly, this would be c, the same, is equal to the same, is equal to ky. Then I have the sign here plus, the next term there is L over y squared. Now, I want you to appreciate something, that the quantities in question here, okay, are x and y. So these other letters you see here, we call this the constants of proportionality, right? So the quantities are x and y. These two letters stand for the constants of proportionality. So the quantities, write this down. So the quantities, okay, are x and y, okay, while k and L, y, k and L, okay, are the constants of proportionality. The constants, just the constants. So the same goes with this. C varies partly as y. So the quantities here are C and y. Every other letter you see here, as you've seen, like K and L, they stand for the constants of proportionality. Alright, so let's do one or two examples. I may need to wipe this part off now. Start off from here. So let's start off with a few examples. So example 1, the first example is this. Let's say the cost of sewing, okay, a material is partly constant to the time it takes to sew the material. So the cost of sewing a material is partly constant. This is the first statement, okay? The cost of sewing is partly constant. Okay, this is the first statement. And the same cost of sewing is partly constant now, okay, to the time it takes to sew, right, the material. So I'll give you values for C and T, which represents the quantities here, right? But meanwhile, let me rewrite this now. This would imply C is equals to a constant. I'll replace this with C equals to a constant, plus I'll replace with an equals to now with a different constant from K, L, and I have the quantity T here, and I have a C here. So I could write this everything as C is equal to K plus LT. K plus LT. So K and L are the constants of proportionality, while C and T represents the quantities. Alright, so let's move on now. So I'll give you values of C and T, two pairs of values. Why? Because I have two constants here, and I have to look for what the K and L stands for. So let's say when the time is 6 hours, okay, so let's say in 6 hours of sewing, the cost of sewing is, let's say, 2,800 naira. And then let's say in 10 hours, the cost of sewing is 3,600 naira. So with these two pairs now of values of C and T, a pair and another pair, we could easily look for what K and L stand for, because this would make, okay, this would make a simultaneous equation right out of this. Then I could now figure out what K and L stand for. Now the question is this: what is the cost of sewing, right? When the time, okay, in 4 hours. What is the cost of sewing in 4 hours? Alright, let's go ahead and solve this. Alright, I need to clear this up for a while. Alright, so let's move on. If you're new to the channel, you may want to like, share, and subscribe for more contents. Alright, so solution. The solution, I have C is equal to K plus LT, where K and L stand for the constants, C and T are the quantities in question here. So I could easily replace this first pair of values for C and T. So C is 2,800. K we don't know for now, the second constant L we don't know, but the time is 6 hours. So this is times 6. So this will boil down to be 2,000. So this will be 2,800 is equal to K plus 6 times L gives, okay, the 6L. So you could only see that I'm left with the letters, right, the constants. So I could easily call this the first equation, equation 1. And I could stick in the second pairs of values of C and T, right, in this relation, this mathematical relation. And I could get the second equation out of that. So C would be 3,600. That was the second pair of values of C and T, is equal to the constant K plus L, and the time is 10. This is 10. So this will boil down to be 3,600 is equal to K plus 10 times L, that gives a 10L. This is equation 2. So clearly there are two letters here which stand for our constants, and I have to figure out what they are. And how do I do this? I have to solve this simultaneously. Alright, let's proceed. Let's proceed. Let's proceed. Alright. So the first equation is okay, solving simultaneously, right? So to find the constants, K and L, okay, solve both equations simultaneously. And of course there are two methods, right? Basically, it could go beyond two methods, okay? But there are basically two methods for solving simultaneously the equation. The first is the elimination method. So you are free to eliminate either K or L, then later replace the value of, okay, K or L to get the other, okay, term. Alright, or value. So let's see. The first equation is this, okay, let me start with the second equation, right? So I have equation 2 is 3,600 is equals to K plus 10L. This is equation 2. Now, please, you are free to choose either of the equations, okay? But for my convenience, I prefer to start with equation 2. Then equation 1 is 2,800 is equal to K plus 6L. This is equation 1. So I'm free now to stick in a plus or a minus depending on the term, the letter I want to eliminate. Okay, so for my convenience, I prefer to use the first method, elimination method. Alright, so now clearly I could eliminate KY because if you look at the term behind K, we call this the coefficient, right? The number behind K, you will see there is an invisible one here and an invisible one here. So it depends on the sign, okay, associated to K. I'm free to use either a plus or a minus, okay, to delete K. Now, it's also interesting to know that there are times, okay, I may not really have the same coefficient, right, for the term I want to eliminate. So what do I simply do? Clearly, I could multiply each of these terms in equation 1 by the coefficient of the term I want to eliminate. So I want to eliminate K now, right? So I'll multiply everything in equation 1 now by the coefficient of K in equation 2, which is 1, right? And I could multiply equation 2 now by the coefficient of K in equation 1, which is what I want to eliminate. So it depends. If I want to eliminate L, I could multiply equation 1 now by 10, right? Each of the terms here, I multiply, right, equation 2 by 6, each of the terms here. It depends on the term, the letter I want to eliminate. So in this case, I want to let go of K, right? Now clearly, the 1, right, leave these terms unchanged. Is that correct? Since the coefficient is, okay, already the same. So what do I simply do now? Let's see. Now, let's see. The 1 doesn't change anything here. So let's see, because K has the same coefficient. But if I wanted to let go or to delete or to eliminate L, right, I'll multiply this equation 2 by 6, which is the number multiplying L in equation 1. I'm multiplying equation 1 now by 10, which is the coefficient of L in equation 2. So for my convenience now, I choose, or I prefer to eliminate K. Of course, I could have done that for the L first, okay? Alright, at your convenience. Alright, so if I stick in a plus now, so I'm going to delete this now, okay? It doesn't change anything. So there is a plus here. Now watch this. Plus times plus gives me a plus, right? So if I have plus K, that will give me plus 2K, right? So clearly I can't eliminate the K using the plus. But I could try the minus now. What is minus times the plus? This is minus, so I have minus K here now. So plus K minus K is gone. So you could see that preferably, right? I could use a minus in this case, right, to eliminate the K. Alright, so let's proceed. Now, minus times plus gives me a minus, right? So I'm left with plus 3600 minus 2800. So just to say I have 0, 0, right? 0, 0. I could take a 1 here. Let me do it here. 3600 minus 2800. 0, 0. Take a 1 here. Oh no, this is 6. I'll take a 1 from 6, cannot subtract this. I'll take a 1 from 3 to make it 2, and I'm left with the remainder 1, which makes this 16. 16 minus 8 is 8, right? Then 2 minus 2, right, is gone. So what I have here is just 800. Just 800. And this is equal to minus times plus gives me minus K. Plus K minus K, right, is nothing, it's gone. Then I have a minus times plus, that gives me a minus. So this term becomes minus 6L, because the minus multiplies the plus to give a minus. And then I'm left with 10L minus 6L. So 10 minus 6 is just a 4. And of course, I have the L common there, right? So clearly, I could look for L now, since I've eliminated the K. 4 in 4 is 1, right? And 4 in 8 is a 2. So I'm left with 200 is equals to L. So I could say, therefore, L is equals to 200. Now I know what L stands for, right? I could replace 200 for L in either of the equations, right? To find K. Alright. Can I wrap this up? Alright. So, now I know the first constant, L, which is 200. So what I'll do is I'll replace, use the word replace or substitute. Replace or substitute 200 for L in either of the equations, right? It could be equation 1 or 2. But I prefer now to use, okay, let me use equation 1. So using equation 1, of course I could have used equation 2 and I'll still get the same answer. So using equation 1, and what is equation 1? This term, equation 1 is 2800 is equals to K plus 6L, that's equation 1. So anywhere I see the K now, I could just stick in 200 there. So I have 2800 is equals to K plus 6L now, stands for 200. So can you see I'm left with the K now? So this would be K plus 6 times 2 is 12, and I have 2 zeros in front, and I have 800. Now I could bring this term here to give K plus, okay, let me write it up here. So I have, let me bring the right hand side here. K plus 200 is equals to the term on the left, 800. Right, so K now, I could keep the K now and transpose, right, the term associated to K here with a plus sign. So I could transpose this and the sign will flip from plus to minus on the other side. So this would be equals to 800. The plus changes to minus here, right, since it's transposed, and I have 1200. So clearly K becomes, this is a 6, this is 6, and this is 1, then I have 2 zeros in front. So 28 minus 12 is 16, and just since you have 2 zeros common, right, that's sticking the 2 zeros. So K is 1600. So clearly now, I know what the constants are. So I could tell you for real the relation between, right, the quantities, and of course in this case is the costs of sewing and the time it takes to sew. So the relation or the formula or the function that relates the quantity, the costs, and the time it takes to sew. Initially we wrote this K plus, right, plus LT. Yeah, I could recall. And we need to box this with So to make this quantitative now, I could just stick in the values of the constants K and L, and this, okay, defines the relation between C and L, and T rather. So C is equal to K is 1/600 plus L is 200, then times T. So this is the formula, or the function. So this is the formula or relation or the function, okay, between quantities C and T. Now I could now go ahead now, since I've established this relation, right, between the quantities. Now I could now go ahead and tell you what the cost of sewing would be, right, given the time to be 4 hours, right? I cleaned that part up. Alright, so I need to rub this part off. Can I rub it off? Alright. So the question is actually, what is the cost of sewing? What is the cost of sewing? Okay, given that the time it takes to sew is 4 hours. Alright, so clearly I've established the formula. C is equals to 1/600 plus 200T. So all I need to do is just to replace 4 for T, and I solve and I'll get the cost, okay? So C is equal to 1/600 plus 200 times 4. And clearly this is 1/600 plus 4 times 2 is 8, and I have 2 zeros in front. So when you add up, right, you find out that we have 1/600 plus 800, this is 0, 0, this is 6 plus 8 is 14, right, 4 carry 1 over, this gives me 224. So this is, C will be, so the cost of sewing in 4 hours would amount to 2,400 naira. Since, right, it was 2/8 for 6 hours, right, the cost for sewing for 6 hours was 2/8. The cost for sewing for 10 hours was given to be 3/6. Now the cost for sewing for 4 hours, right, would be given to, would be given as, okay, 2,400.